Hello everyone. In this video, we're going to look at how we decide which probability formula we should use depending on which situation we're dealing with. So one of the biggest problems I see in this unit that students have is we have a number of different formulas that help us calculate probabilities. Z equals X, or Z equals X bar, Z equals P hat, or the probability of X successes in that ugly mess. And all of those formulas are used to help us calculate a probability. And then as we get into the later part of this unit and move further on in the course, we then use that probability to help us make a decision. But we cannot properly calculate the probability and we cannot properly make a decision if we are not using the appropriate formula from the beginning. So as I said, there are four probability formulas, or four formulas that help us to calculate a probability, but only one of those will be right in the specific situation that we're dealing with. But which of these four is the right formula? Well, let's go through a flow chart together to help us decide which of the four that we should be using. Now, this flow chart is available in the Unit 2 content section, and I highly encourage you to download it or print it out and fill it out as I go through the videos. So please feel free that as I go through the video, pause it in any specific spot and write down the information. The more times you go through this decision flow chart, the easier the process will become for you. Okay? And like I said, this will be absolutely critical in helping us get to the point where we are choosing the right formula. So now, with almost every question in this unit, we should be going through this flowchart. Almost every question is going to ask us to calculate a probability. The only time we do not need to go through this thought process is when we have a question which already has the probability distribution created for us. So here, yes, there is a missing probability. We do not know what the probability with event 3 is. However, we do not need one of those fancy formulas to help us calculate the probability. What we should understand by this point is that all of the probabilities in any distribution need to add up to 1, or 100% of the total outcomes. So here, instead of using a fancy formula to calculate the probability, I can simply do 1 minus all of the other probabilities, and I can easily find this in that way. However, if we didn't know any of these probabilities to begin with, then we would absolutely need to go and think about which of the formulas I should be using in order to calculate the probability of 0.8. Where did that come from? Well, I'll tell you, it would have come from one of these formulas that we're using, but here it's already been calculated, so we don't need to worry about it. As I said, the only time I'm not going to go through this thought process is when I have a question like this, where I have the distribution already created for me. We simply have one missing probability in which I can easily calculate that probability by 1 minus everything else. Every other question, we need to go through this thought process. So getting back to the flow chart, the very first question I'm going to ask myself is this a question about mean, or is it a question about proportion? Now, some questions are going to be very straightforward and it will come right out and we will see the words mean or proportion in the question and it will be fairly obvious. But others, it might be a little trickier, and it's on us to sort of know what a question about mean is referring to or know what a question about proportion is referring to. So one little helpful hint in order to distinguish between mean or proportion questions, because they are significantly different, in a question of mean, we are measuring something. I'm talking about the average fill level or weight or distance. We are taking a measurement of something, a volume, a time, a distance, something that I can use, some sort of apparatus, whether it's a scale or a clock or anything, to take a measurement. That is a question about mean. A question of proportion is completely different. In a question of proportion, we are talking about success and failure. When I look at this specific item, does it meet the trait that I'm looking for or not? It either exhibits this trait or it doesn't. I'm not measuring anything. I just look at an item and I look for a specific trait. Either it has it, yes, it's a success, or it doesn't, then no, it is considered a failure. So having asked myself, is this a question about mean where I'm measuring something, or is it a question about proportion where I'm talking about success and failure? If it happens to be a question of mean, then I next want to ask myself, am I dealing with a single observation or a sample? Okay, so when I'm talking about the things that I'm looking at, my measurements, is my measurement from one item or is it from a group of items? Really, anything more than one. If it's one item, then it is a single observation. If it's anything more than one, then we are dealing with a sample. So if this is a single observation question where I'm simply looking at one item, well, these probability formulas are based on the same theory that we learned about in a previous unit called the empirical rule. And we saw that the empirical rule only applies to that bell-shaped symmetrical distribution, which in this unit we come to know as the normal distribution. So does the question come right out and tell me that the population is normal? I need to know whether the population follows a normal distribution or not, much like I did when I was dealing previously with the empirical rule. If the population follows a nice symmetrical bell-shaped distribution, or now, as we know it, is a normal distribution, if we can answer yes to that, so again, this would have to be told to us in the question. The question comes right out and says, the population is normally distributed. If yes, then we can go and use the probability formula that we want to use. So a question of mean, dealing with a single observation where the population is normally distributed, we would use the formula Z equals X minus mu over sigma. If I answer no to that question, it does not mention the shape of the population, or for that matter, it mentions that the population is negatively or positively skewed. If I don't know that the population is normally distributed, then I cannot do the question. We do not have the math at this point to be able to go and proceed with this question. It would be done. The other route I could go down if this was a question regarding mean is where we're dealing with a sample, dealing with more than one observation. So now I have two options. Much like with a single observation, does the question come out and tell me that the population is normally distributed? Great. If it does, I can go ahead and do the question much like I could before. However, and this theory goes kind of beyond what we need to understand in this course, there is some theory dealing with something called the central limit theorem and the sampling distribution of sample means, where as long as our sample size is at least 30, then no matter what the shape of the population, this will automatically assume a normal distribution. So like I said, all we need to understand in this class is once I'm dealing with a question of mean, and I know that I'm dealing with more than one observation, I have a sample, I ask myself, does the question come out and say that this population follows a normal distribution? Or is my sample size at least 30? If I can say yes to at least one of those two things, I don't need to say yes to both. If I can say yes to one, the question has told me the population is normal, or the sample size is at least 30, then I can go ahead and use the formula that I would like to use, Z equals X bar minus mu over sigma divided by the square root of n. So the only difference between this Z-score formula and the Z equals X formula is in this one, we are dealing with a sample, and we should know by now, I hope, that X bar represents the sample mean, as opposed to in our last formula, where we had Z equals X, X represents a single observation. So really, the Z-score formulas here are sort of giving away why we would choose one over the other. Z equals X for a single observation, Z equals X bar as soon as we have more than one observation or we're dealing with a sample. But again, just because I want to use that formula, I can't necessarily use it. I need to meet one of these two criteria. So if the population is normal, the question would have to tell me that. Or is my sample size at least 30? That is something that we can measure. So if I have at least 30 observation or the population is normal, then we can go ahead and use the z equals x bar formula. If we say no to both of those, then once again, we do not have the math at this point to go ahead with the question, and the question would be finished. So I need to say yes to at least one of those. Well, let's look at the root now, where if right off the start of the question, we said that this was a proportion question. So remember, a proportion question is one in which we talk about success and failure. Does the item I'm looking at meet this criteria or not? What percent of the whole exhibits this trait? Okay, those are proportion questions. Once we have a proportion question, the first thing we do is a calculation. We multiply n times p and n times q. Well, n, as always, is our sample size. P is the probability of success in the entire population. Q, the probability of failure in the entire population. Not in the sample that we took, but in the population. What are they claiming the success rate or the failure rate is in the entire population? So right away, I multiply n times p and n times q, and I want to check those. Are they both greater than or equal to 5? So if n times p and n times q are both greater than 5, well, then we can assume a normal distribution for a proportion question. And we have a z-score formula. All normal distribution questions deal with z-scores. So if I said yes, I did that calculation, n times p, n times q, they were both at least 5, then we would use the normal distribution. But in this case, the z equals p hat version of this distribution. If when I did that calculation, n times p and n times q, if either of those is less than 5, not if both of those, just if one of those things is less than 5, then we need to use the binomial distribution. So to recap the entire thought process, we have our 4 possible formulas: z equals x bar, z equals p hat, or the binomial distribution. But like I said, there's a very regimented thought process that I can use to go and choose the appropriate formula. And remember, I should be going through this thought process with every single question I do. The only ones I don't are where we already have that probability distribution created for us. Not only does this thought process get us to the right by hand formula, but it also gets us to the right function I should be using in Excel. Any of these things that deal with the normal distribution, in Excel I should be using norm.dist. So if my thought process got me to here, I would use norm.dist in Excel. If my thought process got me to here, again, norm.dist in Excel. Once again, here, norm.dist in Excel. Finally, this last option is the only option where I would use binom.dist in Excel. And like I said, the more times we go through this thought process, the more comfortable you're going to get with it. And what we will learn as we get into our more formalized probability or hypothesis testing stuff in the next unit, it's really going to be almost all of the same thought process to get us to the appropriate formula there. So the sooner I learn this, the better. And I will tell you, it alleviates a lot of the confusion about why I'm choosing which of these versions of the z-score or why I'm choosing the binomial distribution. So please, I hope this helps. Go through this chart every single time you do a question other than the ones with that already created distribution for you. And if you have any questions whatsoever, as always, please send me an email.